Hello, this is Math 2115 coming to you from the College of DuPage during the fall of 2020, and this is the second continuation of a lecture entitled The Logic of Quantified Statements. Consider the statement, all mathematicians wear glasses. Many people would say that its negation is no mathematicians wear glasses, but if even one mathematician does not wear glasses, then the sweeping generalization that all mathematicians wear glasses is false. So a correct negation is there's at least one mathematician who does not wear glasses. That leads to this general statement, and it is a theorem. You could prove this with truth tables. The negation of a statement of the form, for every x in D, Q of x, is logically equivalent to a statement of the form, there exists an x in D such that not Q of x. And symbolically, that would say that the negation of, for every x an element of D, Q of x, this symbol means is logically equivalent to, has the same truth value of, there exists an x in D such that not Q of x. Thus, the negation of a universal statement, all R, is logically equivalent to an existential statement, some are not, or there is at least one that is not. The general form for the negation of an existential statement follows immediately from the definition of negation and of the truth tables for existential and universal statements. This is a theorem, and you could build a truth table to see that this is true, but you should know the result. The negation of a statement of the form, there exists an x in D such that Q of x is logically equivalent to a statement of the form, for every x in D, comma, not Q of x. Symbolically, the negation of, and this is parentheses, so the negation is on all of that, there exists an x in element D such that Q of x is logically equivalent to, for every x in element of D, not Q of x. Thus, the negation of an existential statement, some are, is logically equivalent to a universal statement, none are, or all are not. So finally, here's an example for you to do. You want to write negations for these two statements. You're actually doing two examples. You know what to do. Let's see how you did. So if you apply the rules to the first one, for every prime p, p is odd, that would see the negation of that would be there exists a prime p such that p is not odd, or that could be p is even, I suppose. The answer to B, the negation of the statement B, is by applying the rules for the negation of an existential statement, you see that the answer would be for every triangles T, the sum of the angles of T does not equal 200 degrees. Now you have to be really careful to avoid mistakes when writing these statements when they're given informally. And one way to avoid such an error is to rewrite it formally and take the negation using the formal rule. Here's another example for you then. So you want to write these formally and then write the formal and informal negations. We're practicing what we were preaching. You know what to do. Let's see how you did. So the formal version of no politicians are honest is for every politician, X is not honest. The formal negation is there exists a politician X such that he or she is honest, and the informal negation is some politicians are honest. This second one has a trailing quantifier, and so written formally you get for every integer n between 1 and 37, 1357 is not divisible by n. We continue though, so its negation is there exists an integer between 1 and 37 such that 1357 is divisible by n. And an informal version of the negation is the number 1357 is divisible by some integer between 1 and 37. Another important way to avoid errors when taking negations of statements, whether stated formally or informally, is to ask yourself, What exactly would it mean for the given statement to be false? What statement, if true, would be equivalent to saying that the given statement is false? And here's a question that you should be able to answer, and maybe even think about, could I write a program that would test this to figure out if 130, if it's really true or false. Here we're not dealing with it's true or false, we're just dealing with the quantification of it, but here we actually could deal with the truth value. So here's another example. You're to write informal negations using some of the thoughts that we just shared for the following statements. So you've got two problems to do. You know what to do. Let's see how you did. So a couple of ways that you could negate this. First one, that all computer programs are finite. There's a computer program that is not finite, or some computer programs are infinite. If you say some computer hackers are over 40, the negation of that would be no computer hackers are over 40, or all computer hackers are 40 or under. Informal negations of many universal statements can be constructed simply by inserting the word not or the words do not in an appropriate place. However, the resulting statements may be ambiguous and in fact wrong. You want to be very careful here, and that's what this caution is telling you. For example, a possible negation of all mathematicians wear glasses is all mathematicians do not wear glasses. The problem is that this is ambiguous. If I say, emphasizing the word not, it could be interpreted as a logical negation. What? You say that all mathematicians wear glasses? Nonsense. All mathematicians do not wear glasses. On the other hand, if stated in a flat tone of voice, all mathematicians do not wear glasses, it would mean that all mathematicians are non-wearers of glasses. That is, not a single mathematician wears glasses. This is a much stronger statement than just the negation. And so it implies the negation, but is not equivalent to it. Understand this and be very careful. We can also find the negation of a universal conditional statement, which is if-then. So the negation of, for every x, if p of x, then q of x, is logically equivalent to, there exists an x such that p of x and not q of x. You might remember that if p, then q was logically equivalent to p and not q. We did that back in the truth tables chapter. So here's an example. You're supposed to write a formal negation for these statements and an informal negation statement for, well, I guess it's a formal negation statement for statement A and an informal negation for statement B. So there they are. You know what to do. Let's see how you did. And we'll do that in the next video.